Welcome to the third and final worksheet in the Week 10 Spreadsheet Binomial Option Pricing Workbook. And here, what we do is we once again apply a 3-period binomial tree as we did in the previous worksheet. But instead of just applying a European formulae, we are now applying an American formula. And instead of making it a call formula, we'll make it a put formula as well, just to add a little bit of additional complexity. Now, of course, the difference between an American option and a European option is that an American option can be exercised early. So what you need to do in the American option is to look at each node of the tree and work out whether it's optimal to exercise early or whether it's suboptimal to exercise early, and whether we should continue going backwards through the tree to the root. Well, how do we implement this in Excel? Well, it's quite simple. What we do in problem 1 is we find the value of the American put option. Knowing that the stock price evolves in this way, exactly as we've seen in the prior worksheet, we use that stock price to calculate the value of the put option at the leaves of the tree, which of course coincides with the expiry of the option. And because it does coincide with the expiry of the option, we can simply apply the maximum K minus S or 0 formula. Remember, it's not S minus K now because it is an put option. So it's K minus S. So K is $50, the strike price, and S in this top node is $60.50. And in that case, the value of the option is 0. It's 0 in the intermediate leaf as well, but it's positive in the lowest leaf, not surprisingly, because $47 and 0.045 cents is less than the strike price of 50, so the put option has some value. So once we do that, we work backwards, and this is where life gets a little bit more complex. You can see that the formula we apply here is a little bit more complex than what we've seen in the previous worksheet. Why? It's more complex because we now have to consider the possibility that early exercise, which is available for American options but not for European options, may be more worthwhile than not early exercise. How do we evaluate that in Excel? Well, what we do is we embed two max formulas, one within the other. The first max formula says take the largest, either the value of the option if you should early exercise or the value of the option if you should not early exercise. Why is this term equal to the value of the option if you should early exercise? Well, that's equal to the value of the option if the stock price is $55, which it is in this intermediate node of the tree. And if that, or the strike price minus that, is greater than 0, well, it's not, it's less than, so the value of that is actually equal to 0. So the question then is, well, what's larger, 0 or what's on the right-hand side here? Conceptually, what's on the right-hand side represents the state pricing as we saw in the previous worksheet. So all we're doing is we're finding the state price here, using what I've highlighted in black. So in a nutshell, what this term is saying is, give me the largest value. Either the value of early exercise, which is what this max is, or the value of the state price of the option. Give me whichever one is larger and insert that value in this node of the tree, which happens to be 0. And then repeat for this node and, of course, repeat for the root of the tree. And it's as simple as that. The European put option I ask you to do in problem 2, it's actually simpler than the American, but I ask you to do it for completeness. That's it for this week. I hope you enjoyed your introduction to binomial option pricing.